Alright, so very good evening to all of you. I welcome you all on YouTube channel of Unacademy IIT JAM Live. This is your educator Srishti, and in this session we'll be discussing structure elucidation problems using organic spectroscopy techniques. Okay, before we start off with today's session, just quickly let me know in the comment section if my voice is audible. So very good evening to all of you. So am I audible to all of you? My voice is clear. So if it's clear, we can quickly start off with the session. Okay, it's audible. Great. Okay, so let's start with today's session. So today's session is going to be on structure elucidation problems. Okay, so we have completed NMR spectroscopy, we have completed IR spectroscopy, UV spectroscopy, we have completed mass spectrometry also. So we have completed 4 spectroscopy or 1 spectrometry technique, which is going to help us in now structure elucidation of organic molecules. Okay, before these spectroscopy techniques, it's not possible for us to figure out the type of molecule we have. So this spectroscopy techniques have a lot of advantages in your research work too. Okay, so today we are going to practice some basic and some good questions which was asked in like various entrances examination, chemistry based entrances examination. Okay, so without further delay, let's quickly start with the session. So just you have to apply each and every concept that we have learned in the lectures, and now it's the time for some practice. Okay, so before we go to the questions, this is your schedule for July month for test series and special classes. Okay, make sure you make like proper schedule or timetable for these test series so that you can practice some questions also, right? With like concepts, practicing questions is a most important thing. Okay, it's one of the most important thing for your exam preparation. Okay, so you have to practice question also, and basically you have to revise content also. So make sure you make note of these dates and enroll in these test series. So how you have to access this test series, you just have to scan this QR code from your Android phone. So once you scan this QR code, you'll be redirected to the page and you can enroll in these test series. Some of the test series, they are like paid test series for only plus students, and some test series are like free test series which plus students and non-plus subscriber can also access. Okay, so if you want to take like Unacademy plus subscription, if you want to prepare from my courses and other educators courses also, you can use this referral code Srishti B Life 10 for additional 10% discount. With this referral code, you can access my classes, and you can access like classes of every educator present on like Unacademy IIT JAM platform. Okay, so this one referral code will give you access to each and every class, each and every test series and various content in on Unacademy plus platform. So without further ado, let's start with this session. So let's take very first question on structure elucidation. This is really nice question which was asked in CSR net examination. Why this is basically a very nice question, or it's a very important question, because in this spectroscopic technique we are actually going to use IR spectroscopy also, 1H NMR spectroscopy also, 13C spectroscopy also, and mass spectrometry also. So now we are going to use all 4 techniques in this question, and we are going to figure out which of the following is going to be correct answer using these information. So I'm giving you 1.5 minute for like using the concepts that what actually we can do with this question, then I'll solve this question. So like take advantage of this time and think that how we can actually use IR, NMR and 13C information. Okay, so let's use all this information and figure out what's going to be the correct answer for this question. Okay, so everyone please listen to this each and every point very carefully. This one question will help you with a lot of concepts. Okay, it's really a nice question. So let's see how we can approach this question. Okay, first what we can do with this question is always remember few points before start solving structure elucidation problems of like spectroscopy techniques. First of all, you always have to use NMR data. Okay, make these points very right. Just note down these points. These are very handy points, very useful points for you to figure out how you can approach these problems. Okay, first of all, always you have to use NMR data, right? In NMR data also you have to use 1H1 data, then 13C data. Okay, first of all you have to use 1H1 data, then 13C data. After like using NMR data, if you have mass data in question, in IIT JAM level mass data is not going to be provided because it's not in your syllabus. So in IIT JAM question mass data would not be there, but in TIFR masters and CSR net examination, gate examination, maybe mass data would be mentioned. Okay, so next you have to use mass data. If mass data is not mentioned, then you have to jump to IR data. So this is your sequence how you have to solve structure elucidation questions. Okay, first always use mass data. In mass data also 1H NMR first, followed by 13C, then mass data, first NMR data, then mass data, and then IR data. This is the way you have to approach the question. Make this point very clear that never use IR data first. Okay, you don't have to use IR data first. First of all you have to use NMR data, then mass data, then IR data. Okay, so NMR data will definitely cancel out some options. Then like for figuring out which option is going to be correct, then you can definitely use IR data. Okay, but not in the first place. Okay, you have to use NMR data, then mass, and then IR. Let's go back to this question now. So what should be your first step? Your first step should be using NMR data, and in NMR data too you have to use 1H NMR data followed by 13C. So if I would go to these examples, okay, now concentrate. If I would go to these examples, 7.84 peak, 7.60 peaks, can I say these two peaks are for phenyl protons or benzene protons? Can I say this? These two peaks are for phenyl protons or benzene protons. Okay, so 7.84 and 7.60, these two peaks are for phenyl protons and benzene protons. And how we can prove these values? It's a doublet and doublet. Okay, so J value is also 8 Hz and J value is also 8 Hz. And for which coupling this J value is mentioned? Can you tell me? 2J coupling, 1J coupling, 3J coupling, or even 4J and 5J. So can I say this J value is equals to 8 Hz? This is for 3J coupling and benzene. Yes or no? If let's suppose you have one hydrogen over here, one hydrogen over here, this is 1 bond, 2 bond, 3 bond. It's a 3J coupling, right? It's a 3J coupling, or we can say it's ortho coupling. Ortho coupling. And we know in benzene what's the value of 3J or ortho coupling? Somewhere in the range 8 to 6 Hz. 6 to 8 Hz is the range of 3J coupling, right? So using this information, can I say we have benzene with two substituents? It's a di-substituted benzene. Okay, one substituent is going to be over here, one substituent is going to be over here, right? It's a di-substituted benzene. Okay, why? Let's suppose you have X, you have Y, so this hydrogen would be HA, this hydrogen would be HA, this would be HB, and this would be HB, and these two hydrogens would give you doublet for HB, and these two hydrogens would give you doublet for this HA. Okay, so this information is also going with the same right way, that two hydrogens will give you doublet for J is equals to 8 Hz, and two hydrogen will give you doublet for J is equals to 8 Hz. With this information, can I say option A can be our answer, option B is going to be one possibility, option C is also correct, right? It's going to be one possibility, but can I say option D is not the correct answer? Yes or no? Can I rule out option D on this first two information, that we have only two values of benzene, so we can rule out option D. Why we can rule out option D? Because we know the substituents are present over here and present over here. So this hydrogen should give you singlet value, right? This hydrogen should give you singlet value, and there is nothing mentioned over here for benzene value which is going to be singlet. Okay, this hydrogen will give you singlet value, and these two hydrogens will give you doublet doublet, and particularly for this hydrogen you can expect a multiplet when these two substituents are different. Yes or no? This hydrogen will give you singlet, these two hydrogens will give you doublet due to this hydrogen, and this hydrogen will give you multiplet if these two substituents are different. Okay, so definitely this is not the information given in 1H NMR spectroscopy, so we can say option D is not going to be our correct answer. So we can rule out option D on this basis. Okay, we can rule out option D. Now we have option A, option B, and option C. What next we can see? Okay, in option A, option B, and option C, we have this information. Let's see. So next is like all this information: 3.65 for triplet, 3.18 for triplet, and 2.25 for pentate. Okay, this information cannot help us in finding out the correct answer. Okay, now we cannot use this information in order to predict which is going to be the correct answer, because we have CH2 substituents in all the examples. Okay, so now this information cannot help us in figuring out the correct answer. So next what we have to do, we have to go to 13C NMR. Okay, we have to go to basically 13C NMR. Now if I go to 13C NMR, we know this thing that the range is like 20 to 40 is for normal carbon, right? And let's suppose carbon is attached with electron withdrawing group, so the range is like 40 to 80, right? Next we know 100, like 80 to 100 is the range when carbon is attached with like sp hybridized carbon. From like 100 and 120 I can say when we have aromatic, right? 100 to 160 we have sp2 hybridized carbon and aromatic carbons. Then we have like from 180 to 220 we have carbonyl carbons. Okay, so this is like the approximate range we know for carbonyl carbons. Okay, now 13C is not like actually a useful information over here, because it's like 1 2 3 4 5 6 7 8 9 peaks is like given, 9 signals is given for 13C NMR, and in each and every question like we have 9 carbons only, so we cannot use even 13C NMR data to figure out the correct answer. So now we have only cancelled out option 1, and 13C is not useful for us. Now we have to go to IR spectroscopy. Okay, so now let's see what this IR spectroscopy is actually telling us. So IR spectroscopy values 1685 centimeter inverse. Can anyone tell me for which functional group we can expect 1685 centimeter inverse? Can anyone tell me for which functional group we can expect 1685 centimeter inverse? Yes, we can expect this for amides, right? We can expect this for amides, but we don't have nitrogen in the given options, so amide is not one option. Okay, so for like ketones we can say yes, for ketone it's 1750 centimeter inverse. This might be the possibility, 1715. If like the value is 1685 centimeter inverse, can I say the ketone is present in conjugation, that is why there is like decrement in the value? Can I say like this, ketone is present in conjugation, that is why we have 1685 value. Okay, so let's go through options now. This is a ketone which is present in conjugation, this is a ketone which is present in conjugation. If I go to this option, can I say we have acyl chloride? Yes or no? Can I say we have acyl chloride? Can I say like this? In option C we have acyl chloride, and acyl chloride value is, what is IR stretching frequency for acyl chloride? Somewhere in the range of 1800 centimeter inverse. Yes or no? Acyl chloride range is 1800 centimeter inverse, and if acyl chloride range is 1800 centimeter inverse, the value is 1685 centimeter inverse. There's like a drastic change between 1800 and 1685, and that is never possible. Okay, so can I say I can cancel out option C also, that C is not going to be the correct answer? Yes or no? So we have ruled out option C as well as option D. C is not going to be our answer, D is not going to be our answer. Okay, now we are left with two options, option A and option B. Now we have to figure out which option is going to be correct. Okay, now we have used 1H NMR spectroscopy, 13C spectroscopy, IR spectroscopy also, but now it's the time for mass spectrometry. Sometimes what happens, like in net and gate question, if mass data is mentioned in the question, so right, more or less the question is going to be involved around mass data only. Okay, okay. So that is like the trick over here. Over here you have to use mass information, okay. Now let's see how we can use mass information. So those of you who have attended the mass lectures, now you can relate with this question, that how actually we can use mass information. Let's solve this question now. So what else we have to figure out over here? Let's go through this mass information, okay. Let's go through this mass information. So m by z value is 200 and 198, okay. Now can I say this is for m plus and this is for m plus 2? Can I say like this? This is for m plus and this is for m plus 2, yes or no? Can I say 183 is, let's suppose, m plus and 185 is m plus 2, right? These are isotopic peaks. Can I say like this? These are isotopic peaks, m plus and m plus 2, m plus and m plus 2, these are isotopic peaks, okay. Second point is, now if I go to the examples, what all things we have, right? We have which can be present in m plus 2 contribution, okay. Can I say bromine is m plus 2 contribution? Bromine is like present in isotopic form like m plus 2, okay. There's a change of 2 mass unit, 35 right, we have 79 bromine and 81 bromine. For chlorine we have 35 chlorine and 37 chlorine, okay. So bromine is a part of m plus 2 contribution and chlorine is a part of m plus 2 contribution, okay. Bromine is a part of m plus 2 contribution and chlorine is a part of m plus 2 contribution, okay. Now we can have bromine and chlorine in the system, okay. Now we have to figure out one more thing, is like very predominantly present over here in the information. The intensity of isotopic peaks is mentioned, that is 1:1. Can you tell me for which isotope intensity is like 1:1 for isotopic peaks? Is it for chlorine or is it for bromine? For which isotope 1:1 is the intensity ratio? For chlorine or for bromine? Very good, Sonal, it's for bromine, okay. Very good, Pooja, it's for bromine, okay. We know for bromine the isotopic range is very good, Kishan, it's for basically bromine. How we can say that? Because we know 79 bromine is to 81 bromine, right? This is present in 100%. This is the relative abundance of 79 bromine, and for 81 bromine it's somewhere around 98%. So we generally say the intensity is 1:1. Very good, Ambarish, okay. So it's like 1:1 for bromine, okay. So we know that in the system or in the mass fragment that is detectable by mass spectrometry, bromine is going to be present in that fragment, okay. With this information we can deduce that in our fragment bromine is going to be present. Chlorine should be absent from the fragment and bromine should be present in the fragment. Why I can say this thing? Because for both values 1:1 is the intensity ratio. If this, like, if chlorine would have been present in your molecules, it would be like 3:1, but that is not the intensity ratio given in the question. So for sure we can say in mass fragment bromine is going to be present and chlorine should be absent, okay. So with this information we can say that chlorine is going to be absent from the molecule and bromine should be present in the molecule. So these two things are now clear. Now let's see how we can make our fragment, okay. Let's see how we can prepare our fragment, okay. So let's take this first example. Let's take option A, okay. This is your option A, okay. Let's take a fresh slide. Okay, we have 1 2 3, okay. This is our first option, okay. This is option A. Now what we have to do with this question? Alright, can I say this is alpha, everyone, this is beta and this is gamma? Over here we have gamma hydrogen, and if we have gamma hydrogen, so which particular effect is going to be present? Mclafferty rearrangement, okay. So we can say Mclafferty rearrangement can be performed in this system because we have gamma hydrogen. Whenever we have gamma hydrogen we can perform Mclafferty rearrangement, right? So let's do Mclafferty rearrangement. What's going to happen? First step is going to be electron bombardment, right? So in bombardment of electrons, which electron is going to be lost first? Of hydrogen, okay. So we can of oxygen, okay. So we can say this oxygen will lose one electron and a cation would be formed over here, okay, a positive charge and a radical. So this is your system, okay. This is basically your Br. This is going to be your molecular ion peak, okay. What next we can do? This is your alpha, this is beta, this is gamma, okay. Next is, in this case we have hydrogen over here, so this radical, now this bond can rupture, okay. So this hydrogen will take this radical and this bond will take this radical, okay. So next step is going to be basically you have radical bromine, okay, and this oxygen will take this hydrogen radical and it will form OH positive, okay, and there's going to be one radical present over here like this, okay. So now one radical is present over here and one positive charge is present over here. What next we can do? Whenever we have positive charge, alpha cleavage is more dominant, okay. This is actually alpha and this is beta. Now we can perform alpha cleavage over here. So what next we can see? This is like 6-membered ring, a bromine over here, so double bond O, oxygen positive, and over here we can observe one radical, okay. So this radical and radical would combine and this will go in vacuum chamber because it's a neutral ion, okay. So this is going to be formed in basically our step, okay. Now what else we can observe in this case? How this molecule will rearrange. Now this will open up, okay, one radical and one radical, this will open up, and finally you can observe O positive and OH and a radical, okay, and this radical and radical will combine like this, okay. So this is how we can observe this system. Now what next we can write? We can write that this is basically your base ion peak, okay. That, like this we can write this system. It's going to be your base ion peak, okay. Now this is your base ion peak. We know there's a process called tautomerization, so tautomerization will happen in this case, and finally we can observe this system, double bond O and CH3. This is going to be our base ion peak. Yes or no? This is going to be your base ion peak, right? So if this is your base ion peak, so quickly figure out M by Z value for this base ion peak. Calculate M by Z value for this base ion peak. Calculate M by Z value for this base ion peak, everyone. Yes, so what is going to be your base ion peak? How we can calculate? It's very simple. For this benzene, okay, 77 is going to be base ion peak, right? 77 is going to be value. For CO it's 28 and for CH3 is 15, okay. So how much? It's going to be 15 and 20, right? It's going to be 192. All of you are getting 192. It's not 192, basically it's going to be basically 15, 15 and 20, and that would be this would be 200, right? Okay, 192 is not going to be value, basically this is going to be 120, okay. This is going to be this base ion peak, okay. So that is how you can see that definitely this particular ion is going to be formed, okay. So what next we can figure out in this particular question? Okay, 120. So now what we have in this question, see, in this particular question this base ion is formed, okay. So if I go to this first example, bromine is going to be present and this system would be formed. This is going to be basically our ion, okay. So now bromine should be present in our system, okay. Now we have to figure out which is going to be the correct answer, okay. So over here bromine is present and over here carbonyl is present, okay. So we should have bromine in the fragment, okay. So now in this case only we have bromine in the fragment, okay. Only in this case we have bromine in the fragment, okay. So this is how we can take this concept further, okay. Next is in option C, acyl chloride is going to be not possible and chlorine is not going to be present in the system because we know 1:1 is the ratio, okay. Next is if I go to option D is cancelled out by NMR spectroscopy, okay. So option A is going to be the correct answer. So this bromine 1:1 is coming from its isotope, okay. So that is how we can perform this question. So the correct answer for this question would be option A. Yes or no? Is this point clear to all of you? Any doubts? Okay, so what we have basically missed, can I say over here we have bromine also? Just see, just para to this position we have bromine. Okay, we have to add mass of bromine also. Okay, mass of bromine over here, like for every molecule we have bromine. Okay, so we have to add mass of bromine. Okay, so 120 is mass of this fragment, and let's add like 79 over here, okay, of your bromine. So the mass is going to be 19 and this is going to be 199. Okay, so that's how we can figure out the correct answer. Okay, so this 200 is basically for this fragment, this 200 is for this fragment, and 198 is for like basically this fragment, and 200 will come when we are taking 81 bromine. Okay, when 79 is present, 198 will come, and when 81 bromine is present, then 200 will come. Okay, so we have to add mass of bromine also. Okay, so this is how we can perform this question. Correct answer would be option A. Mass would be 98 for the first fragment, and if I would take isotope of this fragment, this would go to 200. Okay, next is if I do like other fragmentation also, let's see that what else we can perform from this question. Okay, so if I take this particular answer, okay, now it's your homework problem. What you have to do, you have to figure out for which fragment we can expect 183. You have to figure out for which fragment we can expect 183, and how you can perform this. Again, for sure chlorine should be absent in the system. Okay, so just take 198. Okay, just take 198 and minus 183 from it. Okay, just take 198 and minus 183 from it. This difference would be 15. Okay, that means there's a loss of 15. Okay, if there's a loss of 15, so what other fragment we can perform over here? Let's suppose this is the first fragment, like this. We have CO and we have CH3. This is the radical ion which we have formed. Yes or no? This is the first base ion peak which we have formed. Okay, this is your base ion peak. Okay, so let's see that for which fragment we can perform it. Okay, so this is the base ion peak which we have formed. Okay, next fragment would be, now pay attention everyone, how we can perform the next fragmentation process. Alright, great. So next fragmentation process would be, first again electron bombardment will happen. Okay, and first of all it will go, right, bromine is present over here and oxygen, and then like one positive charge and one electron would be present. Okay, so CH3 is going to be present over here. What next we can expect? Again this bond will break like this, this bond will break like this. Okay, so CH3 radical will form like this, Br, and C triple bond O positive would form, right, and CH3 radical would be formed. This is going to be your second fragment. Can I say this? Right, this would be your first fragment and this would be your second fragment. Okay, and M by Z value for this fragment is going to be, if you would calculate, this would come out to be 183. Okay, this is going to be 183, and M by Z value for this fragment is going to be 198. So 200 is present when in place of bromine we have 81 bromine. So over here also 185 is present when in place of bromine we have 81 bromine, when in place of 79 bromine we have 81 bromine. Okay, so this point is clear to all of you, that how we can produce these fragments. Okay, this is going to be first fragment and second one is going to be this fragment. Okay, so now you can prove mass information also. Okay, so for sure the correct answer for this question is going to be option A. Is this point clear to all of you? Yes or no? Clear everyone? This is the way we can figure out this question. Okay, I hope this is clear to all of you. Now you can just verify the information. Let's quickly verify the information. 7.84 and 7.60. Why electron not strike the lone pair of bromine? Okay, actually the process over here is, see, it is possible that in mass spectra it will strike the bromine. Okay, it is very much possible, but we have to go towards the stability, and what we have to do, whatever information is given, we have to think the possibilities out of it. Okay, so if I would like, how we can take bromine from here? Yes, definitely fragmentation is possible. Fragmentation is possible from here. Okay, but that would not give you any stable molecule. Okay, so this 198 is basically coming when we are taking Mclafferty rearrangement, and whenever we have gamma hydrogen, that becomes more dominant, okay, that becomes more easy. So we have to go towards the information what is given, okay. Yes, there would be n number of fragments in the mass spectrometry, but we have to go with the value which is given to us, and then we have to think of possibilities, okay. So that's how we are going to do this particular fragmentation, okay. I hope this is clear to you now. Next is, now let's quickly just verify this information. 7.84, 7.60, okay. So we have two hydrogens over here. Definitely this is like your electron withdrawing group. This would be 7.84, this is going to be 7.60, okay. Again doublet, yes, doublet will come from this hydrogen, okay. Alright, doublet will come from this hydrogen, okay. Next is basically J is equals to 8 hertz and J is equals to 8 hertz, okay. This is how I can see J is equals to 8 hertz and 8 hertz, okay. Now if J is equals to 8 hertz, that will come from ortho coupling, okay. Now this is the way we have to approach this question, okay. That will come basically from ortho coupling. Okay, next is basically what we can do with this question. We have two hydrogens over here and two hydrogens over here, okay. We have these two hydrogens and two hydrogens over here, okay. I hope this is now clear to all of you. Next is 3.65, it will come from triplet, okay. So we have this will also give you triplet, this will basically give you multiplet, okay, or pentate we should say. This is pentate, this is triplet, and this is triplet, okay. One is 3.65 and one is basically 3.18, okay. So 3.65 basically will come from here, okay, because chlorine will do increment of how much, 2 ppm. We have discussed this case. Chlorine is going to make increment of 2 ppm value, and this carbonyl will make increment of 1 ppm value, okay. So chlorine will make increment of 2 ppm and carbonyl will make increment of 1 ppm, okay. So that is why higher value will go to this carbon than this carbon, okay. Now you can verify 13C NMR information also. These three values, 128, 130, 133, 137, these values will come for sp2 hybridized carbons, that is aromatic carbons, okay. So we have 1, 2, 3, 4, 5, 6, okay. Basically we have 1 carbon, 2 carbon, these two are same, so 3, these two are same, so 4, okay. We have 1, 2, 3 and 4, okay. So these four values are coming for aromatic carbons, okay. Next is 197, 197 is coming for this carbon, right. 197 is coming for this carbon. Then we have 28 and 36 and 45, so these are coming for these three carbons. Yes or no? This is how I can prove this information. All of you are clear with this point, okay. This is how we can use NMR information also. Rest, how these two values of mass spectroscopy is coming, we know, we have figured out the Mclafferty rearrangement of this particular question, okay. Next is 1685. Basically 1685 is coming from this carbonyl, okay. M by Z is more for bromine, then deflection less. Why not it give base ion peak, can we say? Okay, what's your question? Okay, so basically likewise we cannot say this concept, Sonal, okay. It's a relative concept. So mass and deflection, definitely it matters. M by Z is inversely proportional to deflection, but over here we have to figure out which is basically going to be your a fragmentation process. Mclafferty is predominant over here, so chlorine is attached with this carbon, which will happen in Mclafferty rearrangement. That is why bromine is like present in the system and chlorine goes out of the system. Let's suppose here you have chlorine and here you have bromine, and I would represent 3:1. Let's say I would give 3:1, then you have to figure out in the opposite way that bromine is going to leave the surface and chlorine is going to be present in the molecule, okay. This is how you have to think the question. I hope this clears your doubt, okay. So the correct answer for this question would be option A. And how we can prove each and every information, now you can do by own also, and I have like tell you that this is the way you have to basically approach such type of questions, okay. So I hope it's clear to all of you. Let's go to next question now. Okay, this is your next question. So given molecular formula is C9H10O12O2, okay, 1H NMR information is given. You have to figure out the molecular structure of this question. Okay, let's approach this question now. Let's see how we can approach this question. Okay, so first of all, molecular formula is given to us. 1H Nmr information is given. Okay, the first step should be calculation of double bond equivalent. Okay, this is going to this is basically your first step, the calculation of double bond equivalent. Okay, how we can calculate double bond equivalent? First of all, carbon plus 1 minus number of hydrogens divided by 2 minus, you can say, halogens divided by 2, and you can say number of trivalent atoms or nitrogen divided by 2. This is how you can calculate double bond equivalent. Okay, now let's calculate double bond equivalent. 9 plus 1, that is 10, minus 10 hydrogens, so 5. We don't have halogens over here and we don't have nitrogen over here, so double bond equivalent is 5. Okay, when double bond equivalent is 5, we have to think that first phenyl is going to be present, right? For phenyl, double bond equivalent is 4, and we can say rest 1 extra double bond equivalent is present, and that is going to be for any pi bond, right? This is how we have to first approach this question. So first step is we have figured out that double bond equivalent for this question is 5. So phenyl is present plus 1 pi bond is present. Okay, next is let's use NMR data now and figure out what is going to be your possibility. Okay, so NMR information is when phenyl is present. Let's pick first phenyl data. Okay, let's pick phenyl hydrogens. So 7.6 1H multiplied. Okay, this can be one value. 7.2 1H multiplied, this can be one value. 6.99 1H, this can be one phenyl value. 6.8, this could also be one value. Okay, so basically you have 4 right signals of phenyl. 4 phenyl signals is mentioned. Okay, when you have 4 phenyl signals, so what we can think of substitution pattern of benzene? We know when in case of benzene we have one substituent, so we can either expect one multiplet, only one multiplet, or we can expect 1, 2, 3 signals. Yes or no? First point is clear. Either we can expect one multiplet or we can expect 3 signals when there is mono substitution in benzene, right? So this is not your possibility because basically we are getting 4 signals. Okay, so we can rule out first possibility. Let's go to second possibility now. So second possibility is di substitution, when we have 2 substituents. Now either we can substitute them at opposite positions like this. Let's suppose we have opposite positions, so first possibility is xx basically when they are same, and second possibility is x and y. Okay, this is going to be our second possibility. So when basically it's like this, so we can say over here we should get one value. Okay, basically we should get all hydrogens are same. Okay, so all hydrogens are same over here, so we cannot think of this possibility also because only one signal would be observed then. Okay, so this is not basically going to be the correct possibility. If I would take this substituent, so we can expect like 2 doublets. From 2 hydrogens we can expect 2 doublets. Okay, so we can say this is not your possibility also. Okay, because we have 4 hydrogens. Okay, so we can cancel out this possibility and we can cancel out the next possibility. Third possibility is we can also substitute benzene like this, x and x. This is how we can substitute it, and this is also we can substitute x and y. When I take this substituent, okay, this hydrogen and this hydrogen would be same, this hydrogen and this hydrogen would be same. Again we can only expect 2 signals. Okay, this is not the correct possibility. When I take this case, so this is first hydrogen, this is second hydrogen, this would be third, and this would be fourth. Yes, this is the case where I can expect 4 signals. So with this, after this much of work, this is like my final conclusion that this is going to be substitution pattern of benzene. It's a di substituted benzene, or like you have different substituents on benzene. Okay, so this is how we can approach this way. Okay, I hope it's clear to all of you. So this is your substitution pattern. Okay, great. Now let's pick the substitution pattern. We are clear that this is going to be your substitution pattern x and y. Okay, this is your substitution pattern. Next is, now let's pick this information. Let's not focus on these information right now. Okay, let's not focus on these information. First of all, what can I say? That 2.30, 3 hydrogens singlet, we can think of CH3, right? CH3 is present, and with CH3 you have no hydrogen or some electron withdrawing group is present, and that electron withdrawing group is moderate electron withdrawing group. Oxygen is not present, otherwise the value would shoot from 3. Okay, it's like 2.3, so we can say some moderate electron withdrawing group is present. Okay, at the same time what we can say, there's like one extra double bond equivalent is present, so we can think of carbonyl. Right now we can think of carbonyl, so let's go with that information. Okay, because we have one double bond equivalent also, and oxygens are also present, so we can think of carbonyl. Okay, this is how we can make first possibility. Next is 3.75 2 hydrogens singlet. 3.75 2 hydrogens singlet. Okay, that means, let's say with this end 2 hydrogens are present like this. Okay, this is also giving you singlet, this is also giving you singlet. Okay, when this will also give you singlet, that means from here something is attached, right? From here something is attached. This is how I can say this thing. Okay, that some values basically attached over here too. Okay, so this is how we can think of this possibility. Okay, we have one phenyl, so let's say one phenyl is present like this, right? Let's say one phenyl is present like this. Okay, next is, so if I just look to this information, this is C9H10 OCH2. Yes, we can think of OCH2 also. You are absolutely correct, we can think of OCH2. Let's take the possibilities. Okay, so that you can understand this way, this is O and CH2, and let's take this possibility. Okay, let's say this is going to be our possibility. Okay, when we have this oxygen, right, this particular carbon, this is like 3.75. let's say if we can expect 3.75 or not. Okay, this is a 2-degree carbon, so normal value is like 1.3. okay, what next, this is OCO group attached with this carbon, so the increment is going to be 3 of 3. Okay, plus phenyl is also attached, so this is 3.3. yes, we can expect 3.75 from here. Okay, this is going to be, let's say, first possibility. Okay, let's say this is going to be our first possibility. Next is, what next we can think of, there's like, okay, you have C9H10 O2. Okay, now what all carbons we have like 1 2 3 4 5 6. We have 6 carbons, 7 carbon, 8 carbon, 9 carbon, so there is no carbon left. Okay, what about hydrogen? Right. Okay, so this is basically 2 hydrogen, this will give you a singlet. Okay, let's carry on this way. So basically we have 10 hydrogens, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 and 5 hydrogen. Okay, so we have 5 hydrogens over here, 6 7 8 9 10. Okay, hydrogen is also completed. Okay, then we have what is left, basically 1 oxygen is left only. Okay, there is no oxygen also, but in this way if I would go to this structure, so can I say either I should get a multiplet or I should get like 1 2 and 3 signals? Yes or no? Can I say like this? Either I should get a multiplet or I should get 3 signals. And in this information, if I go with the question, can I say in question broad is mentioned, right? In question broad is mentioned, so for broad signals we can think of oxygen, right? We can think of oxygen, so that means this is not our correct possibility, right? This is not our correct possibility. Can I say like this? This is not going to be our correct possibility. Okay, this is basically our, this is not our correct possibility. Okay, so what else we can think of? We have CH3. Okay, then we have C double bond O. Let's say I have attached CH2 over here. Okay, so next is we can think of like this. Okay, there is one OH also present. Okay, we can think of one OH. So let's suppose it's a bisubstituent, it's a disubstituted benzene, so I would attach OH over here. So just see this molecule and check if it's proving the information, yes or no. Just check out this molecule and see if the value, whatever value is mentioned in the question, this is giving you this structure only. Just check and tell me. Let's verify this information. Okay, so let's use this information. First is 2.30 3H singlet. Okay, 2.30 3H singlet, first is verified. Okay, next is 3.75 2H singlet. Okay, this would be 3.75 2H singlet. Okay, third is 6.8 2H multiplet. Okay, this is one hydrogen, second hydrogen, third hydrogen, fourth hydrogen. Okay, this is 6.99 1H broad spectrum. So can I say this is for this OH 6.99 1H BS, right? This is going to be 6.99 1H BS for OH. Okay, next is 7.12 for one hydrogen multiplet, and next is 7. Let's see. Okay, 7.6 1H and multiplet. Okay, now let's use this information. Everyone please pay attention. Let's draw this formula, okay, and see if this information is giving you the correct answer or not. Okay, this is going to be CH2 C double bond O CH3. Okay, let's say I have OH over here. So can I say this is H1? Let's suppose this is H2, this is H3, and this is H4. Okay, so how I can think of information? First is 2.30 3 hydrogens singlet. Okay, this is 2.30 3 hydrogens singlet. Okay, next is 3.75 2 hydrogens singlet. Okay, next is 3.75 2 hydrogens singlet. This is verified. Okay, next is 6.8 2 hydrogens multiplet. Okay, so it's 6.8, it's a shielded value, so we would say it's like close to oxygen. Okay, so we can say H4 is basically close to oxygen. They are taking 2 hydrogens multiplet. Okay, so if I would take this value 6.99, so let's suppose this value is 6.99 one hydrogen broad spectrum. Okay, next is 7.2 and 7.6. for sure 7.6 would be for this hydrogen, 7.6 would be for this hydrogen because this is close to C double bond O CH3. Okay, so that's how we can say it. And one hydrogen will also give you 7.2, one hydrogen, one hydrogen. Okay, so how many benzene hydrogens? 2 hydrogens. Okay, and over here how many benzene hydrogens? 2 hydrogens. So they have used 4 hydrogens and we have 4 hydrogens over here. Okay, basically they are giving you rough value of this hydrogen and this hydrogen, which is going to be multiplet, right? Which is going to be multiplet. So they have used H2 hydrogen and H4 hydrogen as 6.8 because that is affected from plus M effect of OH, and we can say these two values will give you multiplet. Okay, this will give you multiplet from OH and H3. This H2 will give you multiplet from H1 and H3. Okay, that's how we can think of this possibility, that basically they have mentioned you 2 hydrogens multiplet, irrespective of giving like 4 values, they have mentioned only 3 values. Okay, so 6.8 is basically for this hydrogen and this hydrogen, which is affected from OH plus M effect. Okay, so this is how we can think of this possibility, and the correct answer for this question is going to be, this is going to be your option, and CH2 CO CH3 and OH. Yes or no? Can I say like this? Right? Is it clear, everyone? Any doubts over here? Clear? Okay, this is how we can think of the possibility. Okay, you can also try this question after this class. If you can think of any other possibility, then do let me know. Okay, we'll discuss that possibility also. Let's go to the next question. Yes, we have counted OH signal, Kishan. Okay, OH signal is clearly mentioned in the question. It's how much? It's basically 6.99 1H broad. Okay, it's mentioned in the question. You can think of possibility. Just once again try this question after class. If you can think of any other possibility, then do let me know. Okay. Okay, let's try this question also. So molecular formula is C7H14O3. First of all, quickly find out the double bond equivalent over here. Figure out double bond equivalent. That would be 8 minus 7 is equals to 1. So double bond equivalent is 1, so only one bond is going to be present. Okay, one pi bond is going to be present. So next is, we won't check IR first, we'll go to NMR. Okay, first we'll check NMR, then we will go to IR. Okay, so first of all, what we have 5.2 singlet, 4 hydrogens. So how 4 hydrogens will give you singlet? It is only possible when you have CH2 unit and CH2 unit, which is basically in same chemical environment, right? This is only possible when 4 hydrogens are giving you singlet. This is only possible when CH2 and CH2 is present in same environment, right? Next is 4.1 quadrate of 4 hydrogens. 4.1 quadrate of 4 hydrogens. So how quadrate of 4 hydrogen is basically present? When basically with this carbon you have CH3 and it's of 4 hydrogens, so again it's going to be CH2. Basically you have once again 2 CH2 CH3. Yes or no? So these 2 hydrogens and these 2 hydrogens, they are giving you quadrate from these 3 hydrogens and these 3 hydrogens. So basically you have 2 CH2 CH2 CH3 units and 2 CH2 CH2 units, right? Is it clear to all of you? You have 2 CH2 CH3 units and you have 2 CH2 units. Then only you can say 4 hydrogens are giving you quadrate, because no other possibility is present. Great. All right, next is 1.1 triplet of 6 hydrogens. How 6 hydrogens can give you triplet? When basically CH3 is substituted with CH2, right? Can I say this is the same possibility? They are pairs, they are all together pairs. Can I say like this, right? Can I say they are pair information? Okay, so we have 2 CH2 units, we have 2 CH2 CH3 units. Now just we have to join these units. Okay, so this is a terminating group, this is a terminating group, so for sure the connectivity will happen through this CH2 and this CH2. Okay, so we have to take first CH3 CH2 over here, we have to take CH2 CH3 over here like this. Okay, next is we have to make sure that double bond equivalent will not exceed from 1. Okay, so we can think of like we have 3 oxygens. Okay, we have 3 oxygens, so how many carbons are present? 7 carbons are present. This is 2 carbons, 4 carbon we have used, 5 and 6. That means 1 carbonyl is expected. Okay, let's take 1 carbonyl. Let's take 1 carbonyl. This is giving you singlet, this is giving you singlet. That means you cannot attach these CH2 and CH2 with this CH2 and CH2, otherwise the multiplicity would go to triplet. We have to see singlet. Okay, so now you can see their values also. See over here it's 4.1. okay, let me erase this value. It's 4.1. Next you can see this value is 4.1. and how 4.1 is present for carbon? When carbon is attached with oxygen. Yes or no? When carbon is attached with oxygen, then only we can expect 4.1. That means this carbon should be attached with oxygen, right? Can I say like this? This carbon should be attached with oxygen, then only we can expect C, right? 4.1 value. Next is this is giving you singlet, this is giving you singlet, and see the value, it's also 5.2. that means it is also attached over here like this and like this. Can we say this is going to be the structure? Let's prove this structure now. Okay, let's prove this structure. So how we can prove? For sure this will give you right, this will basically give you triplet, this will give you triplet. So 6 hydrogens, triplet value is 1.1, approximate value is 0.9, so we can expect 1.1. This 2 hydrogens and 2 hydrogens will give you quadrate, right? The value should be somewhere around 3.5 to 4.5. yes, that value is coming. Okay, this is basically for 4.1, this is for 1.1. next is CH2 CH2. yes, definitely these two are singlets, 4 hydrogen singlet. 5.2, why it's 5.2? because it's attached with oxygen also, and this C double bond O also, that is why the value is even more exceeding 4. Okay, so this is 5.2 and this is 5.2. Yes, NMR data is proved that yes, this is going to be your correct answer. Now let's focus on IR data this time. Let's focus on IR data. Okay, so how we can focus on IR data now? Let's see IR data. IR data is basically, first we are getting 2995. So for which functional group we can expect 2995? For which functional group we can expect 2995? Can I say 2995 is possible for CH? Yes or no? It's possible for CH. Can I say this thing? 2995 is possible for CH bond, right? What's the range of CH bond? Range is 2900 to 3200 centimeter inverse. This is the range of CH bond. Okay, so we can say this value is coming for CH bond. Next is 1720. For which functional group 1720? We know for carbonyl it's 1715, right? So 1710 to 1720 is range for carbonyl. So yes, we can say this is basically present for carbonyl. Okay, so yes, this is for carbonyl. 1720 is for this value. Then for CH we have 2995. Next is 1100. We know for, like, basically we can say for CC bond it's 1200, right? For CC bond it's 1200. So we can expect that this value is going to be for OH bond, right? There is no OH bond, so we can say this value can be for OC bond, right? This value can be for CO bond, this value can be for CC bond. Okay, so likewise we can think of such examples. Okay, so always you have to use NMR first, then you have to go to IR value. Okay, so this is how we can say that this is going to be a correct molecular formula. Is this point clear to all of you? Any doubts? Clear, everyone? I hope this is clear, that this is going to be your correct molecular formula. Okay, this is the way you have to approach such questions. Okay, now it's going to be like very simple for you if you have covered 3 or 4 types of spectroscopy techniques. Okay, so we have one last question, and this question is a homework for you. So I want all of you that you should first try this question, and please, I request, don't look for answers to this question. Okay, first you try your level best. You know each and every concept that you require to deal with this question. Okay, we have covered each and every concept in detail, so it, like, you can easily solve this question. Okay, so first try this question all by yourself, then you can think of like taking help from your friends or like from your right educator. First try this question very nicely from the concepts, then I'll definitely solve this question if it's not right clear to you. Okay, so this is how we can solve such questions. Okay, so we have solved 3-4 nice questions today. You can also practice, this is also left, this is also your homework problem. You can also try this question. Okay, so this is how we can practice these questions. Okay, so I take live classes for IIT JAM chemistry and biotechnology, so you can share these lectures with your friends so who are preparing for IIT JAM, for NET or GATE, right? So this lectures will be useful for all type of aspirants. Okay, so this is my referral code. You can use this referral code and you can enroll in this new upcoming batch on Plus platform. I'll see you in the next class. If you found this lecture useful, don't forget to like and subscribe to the channel so that you can be updated with the upcoming classes. Okay, I'll see you in the next class.